In this video, we are going to learn how to make any element or variable in any given equation the subject of the formula. In simple terms, we are going to learn the concept of changing the subject of a formula. Suppose we are given an equation 2x equals to y minus c, and we are tasked to make y the subject of the formula. In making the subject of the formula, the ultimate goal is to employ algebra tactics to get the target variable, in this case y, hold by itself on one side of the equals sign, usually almost preferably the left-hand side. For this problem, to make y the subject of the formula, we must move c to the left-hand side. So on adding c on either side, it becomes 2x plus c equals to y minus c plus c, which is the same as 2x plus c equals to y, negative c cancels out with this positive c, so we have plus 0, which is the same as y equals to 2x plus c, thus making y the subject of the formula. Okay, let's go about some examples. Example 1, make h the subject of the formula a equals to 2 pi r into r plus h. So we are given a equals to 2 pi r into r plus h, and we are tasked to make h the subject of the formula. So to do so, let's move 2 pi r to the left hand side, and to effect that, let's divide either side by 2 pi r. So this becomes a over 2 pi r equals to 2 pi r into r plus h over 2 pi r. And this is the same as a over 2 pi r equals to, this cancels with this, so we remain with r plus h. And to make h the subject of the formula, we have to move r to the left hand side. And to do so, let's subtract by r on both sides. So this will become a over 2 pi r minus r equals to r plus h minus r. Now we have a over 2 pi r minus r equals to, this r cancels with that, we remain with h. So this is the same as h equals to a over 2 pi r minus r. For further simplification, let's obtain the LCM of the right hand side. But how do we obtain the LCM of these variables? Let's do some side work. Suppose you have a half plus 2/3. To add these fractions, we will first obtain their LCM, which is 6. And after obtaining the LCM, which is 6, we will get 6 divided by 2, we get 3. And 6 divided by 3 is the same as 2. So this will equal to 3 times 1, 3 times 1, plus 2 times 2, 2 times 2, all over the LCM, which is 6. And this will equal to 3 times 1, that's 3, plus 2 times 2, that's 4. And 3 plus 4 is the same as 7 all over 6. But we can't obtain the LCM of variables in the same manner as these constants. So how do you obtain the LCM of variables? Suppose we have the same fractions, a half plus 2 out of 3. You can also obtain the sum of these by multiplying 3 times 1. So this becomes 3 times 1 plus 2 times 2. So this becomes 2 times 2 all over the product of the denominators, 2 times 3, 2 times 3. So this will become 3 times 1 is same as 3 plus 2 times 2 same as 4 all over 2 times 3 is the same as 6. And this will equal to 7 out of 6. So if we have variables like 1 out of x plus 2 out of y, to obtain the sum of this, we get the denominator of this times the numerator of this. You will get y times 1 plus the denominator of this times the numerator of this. We get x times 2 all over the denominators multiplied. This is x times y. So this is the same as y times 1 same as y plus x times 2 same as 2x all over x times y same as x, y. This is the same concept you're going to employ here. So for this, we have a silent 1 here. So we have h equals to this denominator 1 times this. We get a times 1 minus this denominator times this numerator. We get 2 pi r times r all over the product of the denominators, 2 pi r times 1, which is the same as 2 pi r. And this becomes h equals to a times 1 is the same as a minus 2 pi r times r same as 2 pi r squared indices all over 2 pi r, thus making h the subject of the formula. Example 2, make t the subject of the formula m equals to t plus 1 all over t minus 3. So we are given m equals to t plus 1 all over t minus 3, and we are required to make t the subject of the formula. So from this, let's first get rid of this denominator. And to do so, let's cross multiply. We have a silent 1, and on cross multiplication, we will have m into t minus 3, which equals to 1 times this. We will remain with t plus 1. So this is the same as m times t, mt, and m times 3 minus 3m equals to t plus 1. Let's correct like terms. And to do so, let's subtract t on either sides. So this will become mt minus 3m minus t equals to t plus 1 minus t. And this is the same as mt minus t minus 3m equals to negative t cancels with positive t, so we remain with 1. Let's move this to the right hand side. We will do so by adding 3m on both sides, and this will become t and t are common, so we have t into m minus 1, then minus 3m plus 3m equals to 1 plus 3m. And this is the same as t into m minus 1. This cancels with this and remain with a 0, so we'll have equals to 1 plus 3m. But we are required to make t the subject of the formula. And from this step, to effect that, let's divide either side or both sides by m minus 1. So this will become divide by m minus 1 and divide by m minus 1. Now we have t equals to 3m plus 1 all over m minus 1, thus making t the subject of the formula. Okay, let's go about this example. Number 3, given that y is positive, make it the subject of y equals to square root of ay squared plus n. So we are given y equals to square root of ay squared plus n, and we are required to make y the subject of the formula. and also recognize that it's positive. So we have this. To simplify it, let's square both sides to get rid of this square root. So we have y squared equals to square root of ay squared plus n, but squared. So this becomes y squared equals to, the square root cancels with the square, so we remain with ay squared plus n. Let's correct like terms. Let's move this to the left hand side. And to do so, let's subtract ay squared on both sides. This becomes y squared minus ay squared equals to ay squared plus n minus ay squared. This cancels with this, so we remain with y squared minus ay squared equals to n. But y squared is common, so it's the same as y squared into 1 minus a, and this equals to n. But we are tasked to make y the subject of the formula, so let's get rid of this factor by dividing both sides by 1 minus a. This will become over 1 minus a, also over 1 minus a. This is the same as y squared equals to n all over 1 minus a. But the problem tasked us to make y the subject of the formula, not y squared. So let's introduce a square root on both sides. This will become y squared equals to n all over 1 minus a, but both sides under a square root. So this is the same as y equals to square root of n all over 1 minus a, thus making y the subject of the given formula. We are given this example 4. Rearrange 1 out of u plus 1 out of v equals to 1 out of f to make u the subject of the formula. So we are given 1 out of u plus 1 out of v equals to 1 out of f. And we are tasked to make u the subject of the formula. For this problem, let's first move 1 out of v to the right hand side, this side. And to do so, let's subtract 1 out of v from both sides. So this will become 1 out of u plus 1 out of v minus 1 out of v, and this equals to 1 out of f minus 1 out of v. So this is the same as, this cancels with this, positive and negative. Now we have 1 out of u equals to 1 out of f minus 1 out of v. But from our problem, we are tasked to make u the subject of the formula, not 1 out of u. And to do so, let's first obtain the LCM of these variables on the right hand side. To obtain the LCM of something like this will become 1 out of u equals to this denominator times this numerator, which is 1 times v, minus this denominator f times the numerator of v, which is 1 times f, all over the product of the denominators. So this is the same as f times v. And this becomes 1 out of u equals to 1 times v is the same as v minus 1 times f the same as f all over f v. But from our problem, we are tasked to make u the subject of the formula, not 1 out of u. For this, we can obtain the reciprocal on both sides. So this will become u out of 1 will be equal to f v out of v minus f. If you really believe that 1 out of 2 equals to 1 out of 2, a half equals to a half, Then if you obtain the reciprocal on both sides, it will be 2 out of 1 equals to 2 out of 1. This makes sense mathematically because 2 equals to 2. This is the same as 2 equals to 2. And this makes sense mathematically. So this implies that therefore U will equal to VF all over V minus F, thus making U the subject of the formula.